Well, Natalie, here's some help, hopefully, on the questions you were asking about in your email. Number 35 has only one trig function. It's quadratic in form, so we want to set it equal to 0. So I'll have 9 sine squared theta minus 6 sine theta minus 1 equal to 0. And that doesn't look like it's going to factor to me. So we're going to have to use the quadratic formula. So sine of theta will equal negative b to be positive 6, plus or minus the square root of b squared to be 36, minus 4 times a is 9, and c is negative 1. All over 2a would be 2 times 9, or 18. So sine of theta will equal 6 plus or minus, that square root's going to end up being the square root of 72, which would be 9 times 8. Well, let's do something different than that. Let's go 36 times 2. That'll be easier. So let's go 36 and 2 with that. And then that way we can square root there's 36 and get 6. So really we'll have 6 plus or minus 6 root 2 over 18. If I factor out the 6, I have 1 plus or minus root 2 left inside over 18. And then 6 will cancel with 18 and make 3. So I simplified that to see if maybe we would end up with something on the unit circle. And we don't. So now let's get a decimal, and then we can go to our calculator. So sine of theta will equal, and if we take 1 plus the square root of 2 and divide it by 3, we'll get 0.8047. And if we take 1 minus the square root of 2 and divide it by 3, we'll get negative 0.1381. And if we sine inverse those two, I better make sure I'm in, this was a problem in degrees, wasn't it? Okay, and I'm in degrees. So if I sine inverse 0.8047, I get 53.58 degrees. And if I sine inverse negative 0.1381, I get negative 7.94 degrees. And now we're going to have to do some thinking, because we're supposed to solve this on the interval from 0 to 360. So, let's think about the 53.58 first of all. Think about that in terms of the unit circle. It would be over here in the first quadrant somewhere. Do you see that over here in the second quadrant, I would have an angle that had the same y value as 53.58 degrees? This angle is 53.58, so the angle over here with the same y value would be the angle that would make this reference angle over here 53.58. So I could get that by taking 180 minus 53.58, or 126.42. Okay, this angle here is not even on the interval from 0 to 360, so I'll add 360 to it to get an angle that's coterminal. That's 352.06. Now, let's go back up here and think through that again. 352.06 is going to be just shy of 360, be right in there. There'd be an angle over here that has the same y value as that. This angle is going to have the same reference angle as this angle. Okay, so if we think about the reference angle here, it'd be 360 minus 352.06. It makes it 7.94, which means this angle has to be 7.94 degrees past 180, or 187.94. So there are all the angles on the interval from 0 to 360 that would solve the original equation. That problem got a little tricky at the end. Okay, this next problem, number 65, we're supposed to solve on the interval from 0 to 2 pi. Okay, and we have cosine of 2x equal to root 3 over 2. So probably the easiest way to approach this problem is to think about all the things that 2x could be equal to. But to do that, first we got to go over here and think a little bit. If x is between 0 and 2 pi, then that means 2x would be between 0 and 4 pi. So I need all the values on the interval from 0 to 4 pi that have a cosine of root 3 over 2. Now, we know pi over 6 is one of those. We know 5 pi over 6 is another. Both of those are between 0 and 2 pi. If I add 2 pi to pi over 6, I get an angle that's coterminal with pi over 6. Well, if you do that, you'll get 13 pi over 6, because 2 pi is 12 pi over 6, plus pi over 6 is 13 pi over 6. And if you add 2 pi, or 12 pi over 6, to 5 pi over 6, you'll get 17 pi over 6. Now, if we divide all four of those equations on both sides by 2, that's going to put a 2 in each one of these denominators on the right side and make those denominators 12. So using the same logic, this one's going to end up being 5 pi over 12. This one will be 13 pi over 12. And this one will be 17 pi over 12. So there are your four solutions. Another thing you could have done on that problem is you could have used a double angle identity for cosine of 2x. Maybe replaced it with 2 cosine squared x minus 1 and worked that way. You probably would have ended up with decimal answers for these four if you did that. Okay, what's next? 75 has sine of x equal to sine of 2x on the interval from 0 to 2 pi. Okay, so I'm probably going to think in terms of replacing this double angle. I don't like double angles. So if I do that, I'd have sine of x equal to, and sine of 2x is equal to 2 sine x cosine x. Now it's got two trig ratios, so we want to set it equal to 0 and factor. So 0 would equal 2 sine x cosine x minus sine x. Could factor out a sine x then. That'll leave 2 cosine x minus 1. So sine x equals 0, or 2 cosine x minus 1 equals 0. So on the interval from 0 to 2 pi, sine is 0 at 0, and sine is 0 at pi. Over here it would mean that 2 cosine x is equal to 1. So cosine of x is equal to 1/2. And cosine is 1/2 at pi over 3 radians. And it's also 1/2 at 5 pi over 3 radians. So 4 solutions. So here's 7.4, number 60. We're given sine of theta is negative 4/5. We're asked for cosine of theta over 2. So I pulled out the half angle identity for cosine. So cosine of theta over 2 will equal, now let's think about the plus or the minus. If theta is between 90 and 180, then theta over 2 has to be between 45 and 90. And between 45 and 90, cosine is positive. It's going to be positive the square root of 1 plus, I'll have to figure cosine of A, and then put it over 2. To figure cosine of A, I know cosine squared theta is 1 minus sine squared theta, or 1 minus 16/25. So cosine squared theta would be 9/25. So cosine of theta is plus or minus the square root of 9/25, which is 3/5. Now, theta is between 90 and 180, and on that interval, cosine is negative. So it has to be negative 3/5. So basically, I have 1 minus 3/5 over 2, and then square root of the whole thing, and simplify that. To simplify that, I'd have to have common denominator, so I need a 5 down there and a 5 up here. So what have I got? Cosine of theta over 2 is the square root of 5 minus 3 is 2/5 divided by 2, which is the same thing as 2/5 times 1/2, which you get the 2's to cancel. It would be the square root of 1/5, or 1 over the square root of 5, or the square root of 5 over 5. Your book says negative, and I figured out why. I miscopied the problemo. If I go back to here, it didn't say 90 and 180. It was number 59. It said 180 and 270, which means theta over 2 would be between 90 and 135. And on that interval, cosine is negative. Okay. Now, that meant over here, when I got cosine of theta, theta is between 180 and 270. That's still in the third quadrant, so cosine is still going to be negative, so that was okay. But our answer should have been negative. Sorry about the confusion there. But I just miscopied that part. So it's negative square root of 5 over 5. Okay, and finally 7-7, number 51. On part A, we're asked to solve this equation for t. Okay, so let's get the trig ratio by itself first. I'm going to divide by E max on both sides. So I have E over E max equal to the sine of 2 pi ft. Okay, and then we can sine inverse both sides to get rid of the sine. So I have the sine inverse of E over E max equal to 2 pi ft. And now we can divide both sides by 2 pi f, or multiply by 1 over 2 pi f. So 1 over 2 pi f sine inverse of E over E sub max would be equal to t. Okay, that's part A. Now if I go to part B, let's plug in the values that they give me. So they tell me that E max is 12. We are told that E is 5. So I'll have the sine inverse of 5/12. Over here I got 1 over 2 pi, and we are told that the f is 100. Okay, now let's see what we can do with that. Okay, so if I sine inverse, and looks like I need to be in radians here. We're talking about pi's. So I'll make sure my calculator's in radians, and it is. If I sine inverse 5/12, I'll get 0.4298. And if I take that times well, really I need to let's think about lost everything. Sorry, let me do this again. If I sine inverse 5 divided by 12, this part, this 0.4298 is what it rounds to. And I'm multiplying that by this fraction. When I multiply that by the numerator, I'll just get 0.4298, and then I'll need to divide by 2 pi times 100. So that's what I'm going to do. So if I divide by 2 times pi times 100, all in parentheses, I get 6.84 times 10 to the negative 4 is equal to t. Okay, so as a decimal, I'd move the decimal 4 places to the left. They give me 0.000684, which is same thing your book has. It rounds to the 8. Same idea. Okay, I think that's all of them. So I hope this helps, and let me know if I can help you any further.